Now let's move to the panel discussion. So what I have is really a wonderful panel representing from the research and market overview point of view. That's Kaining from Forschungszentrum Jülich, and Peter Wolf representing the production equipment wing of heterojunction, and Zhou from Huasun representing the manufacturing. So please switch on your cameras. Kaining, let's probably make it a one-on-one Q&A. Anyway, we don't have a lot of time also. You know, I just want to take our top modules feature as a lead to our panel discussion. So, you know, it's really interesting to see that heterojunction, how the heterojunction technology has been developed over this year. So, as for the technologies beyond PERC, several companies worked and installed pilot lines on both technologies, you know, TOPCon and heterojunction. But it looks like TOPCon is certainly getting somewhat more popular with top-tier companies who have announced several gigawatt of expansions. At the same time, heterojunction is also entering into the high-volume production, and you know, there are multi-gigawatt plants. Of course, no one can match heterojunction in terms of the announcements or the expression of interest, which you have shown in your slide. So does this mean that heterojunction and TOPCon technologies will coexist? And if yes, how will this look like also in the midterm, because you are saying so much?
Yeah, thanks for the question. I think it's a little bit related to the rationale of the technology choice in the moment. I think everything is very dynamic. Okay, so I think there is not a definition of a status. What I want to say is, I mean, the rationale for a company is at the end to earn money with as least risk as possible, with as much gain as possible. So I think a choice of a technology depends a little bit on the assessment of these aspects. And every company with its background and its situation will have a different outcome in risk and opportunity assessment, choosing different technologies. Yeah, I mean, for TOPCon, I think all these well-established PERC manufacturers, I mean, they have experience in PERC, and which can also be seen as a little bit burden, as they have invested a lot of time and money into the R&D of TOPCon, and the cost and the cost and the efficiency ratio of TOPCon is also reasonable. So I think for them it's very, very straightforward to go towards TOPCon. But if you look at heterojunction, so if you will mainly see newcomers that are more active. So all these established manufacturers are having some pilot manufacturing. Most of them have some pilot manufacturing, and just observing this field, because I think in reality the cost is still somewhat higher than TOPCon. And therefore these newcomers choose heterojunction because when they do their risk and opportunity assessment, they see that going for TOPCon, they will be taking some significant disadvantages with them, because they do not have this experience, existing experience, and this long-term investigation R&D, and also there is no good, real good turnkey solution provider in the moment for TOPCon. So for them, if you do a risk and opportunity assessment, I think a newcomer would say, I would enter heterojunction, try to become as big as possible in the meanwhile, and on their way there, the cost potential should come down. So this is a little bit the game people would try to play as a newcomer. This is how I would see this situation. If you have a look at the efficiencies, I think at the end, the efficiency level of both and also the potential of the efficiency go in the similar direction. I don't think heterojunction will be able to come with a delta in efficiency to compete with TOPCon, but I think heterojunction needs to come down and compete directly with the price at the end. Yeah, so I think it's going. It's my personal opinion. I think things will consolidate. Yeah. But I think the TOPCon heterojunction still has a learning curve to do with price coming down, because the TOPCon has already done this, because a large fraction of it is a PERC. Yeah, so, and PERC has already done this cost reduction learning curve. So when the heterojunction has done the learning curve, we need to see where the price will be. And I don't think, as the experience we have with crystallized silicon, things are consolidating at some point. So I don't think both technologies will exist in the long term, but in the midterm, because things are so dynamic in the moment, these two technologies are still open in race. Yeah. So you're muted, Shravan.
Peter, would you like to add anything? Especially company background and efficiency races, and also the TOPCon versus heterojunction.
I think was already a very good explained by Kaining, that I think it's the assessment of the company. So what are going next? What we're seeing from the data, we see what we have in HJT. I think the HJT have some advantages when you put the models in the field, better temperature coefficient, a long time reliability. So there are also some points to be considered. And what is very important for HJT, what I also is my personal opinion, the potential to reduce cost is quite huge. And this will be, I think, the very important point in future. If HJT module production can be on the level or even below the level of PERC or TOPCon, then we have a comparison, a direct comparison. So this is what I think. Once the cost to produce a HJT coming down, then it will be, I think, the successor of the existing technologies.
Okay. I saw Zhou was online. Are you Zhou?
Yeah.
Okay, so would you like to add anything apart from what Peter and Kaining just said?
Okay. Sorry. The surround here is a little noisy.
Okay. Yeah, you can be brief.
Yeah, you may ask.
No, I mean, now the TOPCon seems to be ahead in the race for heterojunction. So that means heterojunction and TOPCon are going to coexist. And, then if yes or no, so what's the midterm idea from you? So how it's going to look like?
Okay. We think TOPCon and the heterojunction will coexist for a long time. For example, like 2025 or 2026. And to the end, there will be one main technology, I think. And for the time between now to that time, they will coexist for quite a long time.
Okay. So then what are the three key topics of development for heterojunction? Kaining?
I think this is three topics surrounding the three triangles of a PV product. Yeah, that's the cost, reliability, and efficiency. I think on the cost side, I think many colleagues here have reported on it. It's about getting away from the silver. It's a major research topic, and on the reliability level, it's about long-term stability, and on the efficiency side is the introduction of the nanocrystalline silicon, and hopefully in the new futures, introduction of the nanocrystalline silicon oxide. Yeah, so this, I would say, in my opinion, would be the three topics.
Okay.
No.
Peter?
Yeah, I also think this is the main topics, and I also think there's much more work to do on the module side than on the cell side, because on the module side it's still in the beginning of the development. So you cannot compare this with PERC, where we have already more than 10 years on development on module side, and I'm very sure with better module connection technologies, we will see a huge progress also on the HJT module side.
Okay. So that means, apart from the cost, is it the module side that has to really improve what you are saying?
Yeah, there's a lot of potential still on the module side. There's a lot of potential. It's still in the beginning to put this in a mass production as a mass product. So we have only two major technologies on the connection side, but there are so many things ongoing with interconnection, different kind of interconnections. And once these technologies are mature and you can bring this in the market on a very low cost, then I'm very sure that we will see quite an advantage of HJT models. Yeah. As you know, we have now main technology is MBB or SMBB technology. We have this. The other idea is the smart wire technology or wire technology. So this is the main, the two mains, but we still not look in what could be happen if we do a very nice shingling or half cell shingling with the ECA paste. What is the cost? And so there's a lot of things ongoing in the market, and I think we will see the next 24 months a really dynamic changing of these ideas, and there's a lot of potential for HJT modules. Yeah.
Oh, okay. So what are the top 3 topics of development for heterojunction in your view?
I think the first one is wafer, and the second one is metallization, and the third one is encapsulation.
Oh, okay.
Yeah.
So, we always talk about the efficiency and its a comparison. So what should be the efficiency delta for heterojunction compared to TOPCon or PERC, so that the technology still makes economic sense?
Yeah, I think because of the PV industry was ultimately to generate power, and the cost should be the top priority. Efficiencies are also for the cost down.
But what do you think should be the efficiency difference between the PERC and heterojunction, so that even you're putting more, all that is going to make sense? So what should be the efficiency difference? 0.5% or 1% absolute?
It's about like 1%, I think.
1%.
I don't think, Shravan, I don't think personally, okay, so no offense. I don't think this is the right question. Yeah, so because I don't think there will be, I mean, we shouldn't underestimate the potential of TOPCon either. So I don't think at the end it's going to, if I look at these two different technologies in the mid or long term, I don't think that it's going to be an efficiency gap that defines how successful heterojunction can be. At the end, it's going to be the cost per watt. Yeah.
Yeah, from my side, I also would say the definition of efficiency for the HJT module it's maybe not the right way. I think we need to really look in the power. That means in the power generation and on the LCOE. So if the power generation LCOE, even on the same efficiency level, is still higher for HJT. So if your LCOE comes down below level of TOPCon, what we're seeing already, then the efficiency, it may not be the greatest or the biggest impact.
But do you think
also
that,
only a personal thing?
Sure. I mean, no, that's really great. But do you think is there any power gap at the module level, significant? But this also depends on whom you are talking to. If you talk to PERC and TOPCon, so they always show that it has higher power than the competitive technologies. But in your experience, do you see the power gap?
You ask who?
Yeah.
I would say it's a physical thing. So if you look in a HJT and the general data with a low efficient temperature coefficiency, then of course in some area HJT modules simply produce more power. It doesn't matter what is the label on the module, simply produce more power. And this is I think it's the key to come to a low LCOE. And when you can achieve a low LCOE, then you are on the winner on this side. Because who buy this module, who wants to have the highest power output? That means the highest profit gain. And this is why I think the HJT modules, even on the same efficiency level as TOPCon, still for certain areas or most of the areas have still an advantage on LCOE.
Yeah. So Sharavan, just I wanted to look at this on the long term, because as also Zhou said, in the long term there is going to be eventually a decision, but not in the midterm. So if I look at the long term, I think what needs to happen is we cannot rely on that the module, heterojunction module, will automatically have higher power than a TOPCon module. But what I think needs to happen is all this cost potential of heterojunction we see being realized, bringing it to a position where it's competitive on the cost level. So I don't think if you want to become a mainstream, at the end, as Peter said, you need to be better with your LCOE and just cost per watt at the end. So I don't think there has to be a efficiency gap in for now. Yes, because for now heterojunction is considered a premium product. Because it has not done its learning curve on cost yet.
Okay. So then moving to the manufacturing. So I just would like to have, from each of you, the top one development at each of the process, like wafers. So what's the key in wafers? So is it apart from thickness reduction, or is it the thickness reduction? Kenny?
Yes. I can answer this question.
Yeah, please.
The thickness is the most important, and the other things is the silicon material we used in the wafer. We use high quality material, or we can use some low quality material like FBR. It also makes good sense.
Okay.
Yeah.
And Kenny?
I can't really comment on wafer. I'm not an expert on wafer.
Okay. And Peter, so what do you think should be done at wafer?
Yeah, of course. One point is the wafer thickness to reduce the general cost of polysilicon, and then what Zhou also say. If you can use, let's say, not this high purity material, also to produce N-type wafer with different dopants, different processes, I think this would be very, very helpful, really, to decrease also the cost level for the HJT.
And
On
in terms of the main core process, so Peter, can you shed a more light on TCO level? So how this AZVO is coming up? So you already mentioned your tools are ready with AZVO partially.
ISO,
So,
yeah. Okay.
Yeah. So can you shed a more light onto that?
Yeah, in general, of course, we're looking in all possibilities to reduce cost. But if you're using AZO, also the performance parameter will change, and you may have to compromise a little bit on the performance. So, and the ITO, the indium silicide, actually is only a very small part on the whole cost cake. So it's very a small part. So the question is really, at the moment, did it really make sense to really do so much effort on this? Because according to some statistical data, we will get in a little bit shortage if we have a 100 gigawatt on HJT cell production. So we are quite far away from this. There's a possibility, of course, we can do this kind of sandwich stack PVD coating to reduce the cost, maybe using only 60% of ASO, 40% of ITO. But actually, then you also have to compromise a little bit on the cell performance. So the question now is, for the moment, because at the moment, as the information I have, there is enough ITO available. And it makes maybe not actually too much sense to push in this direction at the moment. It is possible, yeah, but also AZO material have to improve. You know, reflection is different, performance data are different. So this will be let's say a balance between cost and performance. But at the moment, I don't see any shortage on ATO. So then the question is, why it have to be done?
Okay.
Why it have to be done? Of course, if you're going to a 100 gigawatt HJT mass production factories, then we may get a little bit in a shortage problem, and then we have already the tools, we have already the ideas and the process, and I think Kaining can elaborate a lot on this. Yes. From material science of view, and but actually at this moment I would say it's not really, we don't need to push too much in this direction, because it's only a very small part of the cost, of the total cost. I think more important things are the metallization, reducing of silver cost, and also wafers 50% of the cost of the cell. So yeah. This is the topics, they are more hot at the moment. Yeah.
Okay. All right. So, you know, since we are running out of time, so I would like to ask you one final question. So what is the most important next task for each of you to support and speed up the transition to heterojunction? Kaining?
I think, yeah, one. I think a job of Research Center Jülich is to support the installation of a full heterojunction PV value chain in Europe. Yeah, this is what our mission is.
And Peter, for you?
Yeah, for us the topic is, at the moment we put a lot of resources and also a lot of investment to improve the metallization of the HJT line. Yeah.
Oh, okay. And Zhou? Are you on mute?
Yeah. For our module and cell factory, I think it is integrate all the process equipment and material and to reduce the cost.
Okay. Okay, so thank you very much for your time and energy and your great insights and thoughts. Thanks a lot. I really learned a lot, and probably I would reflect most of them in our upcoming heterojunction report. Thank you, everyone, once again.
Thank you.
Bye-bye.
Okay,
bye-bye.